Hello and welcome. Have you ever wondered how your habits compare to others? Like how much people spend, how much they sleep, or how much time they spend on their phone? Today we are going to use dot plots to answer real questions about real life. Things like cars, money, fitness, and technology. This is not just about making graphs. It is about using data to make decisions and understand what's typical and what's not. You will be looking at different situations and asking what is most common, what is unusual, and what decisions should I make based on the data. As we go through these problems, I want you to look for patterns, explain your thinking, and use evidence from the data, not just guesses. Before we solve real world problems, we need to understand how to read a dot plot. This graph is powerful because it shows every data value clearly. Each dot represents one data point. So if you see a stack of dots, that means that value occurs multiple times. For example, look at 26 and 28. Those have the tallest stacks. This tells us those values appear the most often. From the dot plot, we can identify the followings. The minimum, which is the lowest value. From the graph, we can see 25 is the lowest value. Similarly, we can find the maximum. From the graph, we can see 35 is the maximum value. We can also find the range of this data, which is basically 35 minus 25. We can also find the frequency. For example, frequency of 27 is 2. Frequency means the number of times the value is repeated. Next is the mode. Mode is the value with the most dots, the tallest stack. Here we actually have two modes, 26 and 28. Next is the median. Median is a middle value when all the data values are arranged in order from least to the most. So if you arrange all this data value from 25 to 35, the middle value is the median. If you count from here, the eighth value is here, 28. And if you count from here towards the center, you again get the median as 28. Now let's look at the shape. Is it balanced or is it stressed? More to one side. That tells us if it is symmetric or skewed. In this case, it is stressed towards the right because of this outlier. So this is skewed data. Next is the cluster. You can see most data are clustered between 26 and 28. And there are gaps between 31 and 35. There is no data value here. And I already talked about the shape earlier. And you can see this data and graph also tells us the outlier, which is 35 miles per gallon. This data point does not belong to these clusters. Now let me check if you can read the dot plot or not. What is the minimum value? If you know the answer, write in the comment section. What is the maximum value? What is the range? What is the frequency of 14? Does the da- is the data balanced or is it stretched more to one side? Give me a thumbs up if you agree or thumbs down if you don't. 18 is the mode because it appears multiple times. Why is 30 considered an outlier? Now, if you know answer to all these questions, that means you can read the dot plot. If not, you can always go back and watch the previous slide. Now let's apply what we just learned to a real decision. Manuel wants to buy a car with 26 miles per gallon and he wants to know, is this a good deal? So he collected data from 15 other cars. So to make a decision, let's first create a dot plot, then we will read that dot plot and make the decision. To make the dot plot, first of all, let's draw a number line. And this number line must contain the values, the list and the highest value from the data. So the number line will range from 25 to 35. So let's go ahead and write a number line here. The numbers must be equally spaced. Then we will start putting a dot for each data value. Okay, we'll also label what is this. So these data are the fuel efficiency in miles per gallon. Now let's put there is 125, so we'll put one dot where the 25 is. Next, there are 426 values, so we'll put the 426 values here. Okay, and we are highlighting this because that's what manual car is, 26 miles per gallon. And each dot is representing one car and a stack of dots is equal to more cars with that value. So we have so far two cars with that has 26 miles per gallon average. So there are four cars that has 26 miles per gallon fuel efficiency. Similarly, there are 227 cars. So this is one car with 27 miles per gallon fuel efficiency, and this is another car, so two. Similarly, there are 428 values, so let's go ahead and put the four dots. There is 129 values, so one dot, with 30, one dot, with 31, one dot, and with 35, one dot. Now that we have a dot plot here, what do you notice now? I see most of the data are clustered between 27 and 29, or you can say 26 and 28. This tells me most cars are getting better mileage than 26 because there are so many cars with that has fuel efficiency of 27 miles per gallon and 28 miles per gallon. Also 29, 30, and 31 miles per gallon. So where does manual cars fall? At 26 miles per gallon, it is actually below the main cluster. So based on the data, this is probably not the best deal because most cars have better fuel efficiency. Would you buy this car? Why or why not? Now let's look at a situation many of you can relate to. Alia watches about 3 hours of streaming per day and she wants to know, is that typical? Let's create the dot plot together. Then we will make decisions by reading the dot plot together. Just like said earlier, let's create a number line. Here, the number line will start at 1 and ends at 7. Now we will write the short description. What does this number line is about? It is about daily streaming hours. Now we'll go ahead and plot the value. There are two ones, so there must be two dots. Next is three twos. So one, two, three. Now there are four threes. So 1, 2, 3, 4. And I'm highlighting this because Alia is comparing her 3 hours to the rest of the data. So now there are three fours. So 1, 2, 3. Now three fives. Similarly, 2, 6 and 1, 7. Now that we have a dot plot, we have created the dot plot. What do you see? I see that 3 visits is the most common, and that's the mode. What values do you see the most often? I notice that 3 hours has the tallest stack. That means it is the mode. The data is pretty balanced around 3 and 4. This tells me 3 hours is right in the center of the data. So Alia's screen time is typical, not too high, not too low. Let me ask you this. If someone watched 6 hours, would that be typical or unusual? Explain from this dot plot. Now let's look at another decision, this time about fitness. Jordan plans to go to the gym 4 times per week. He wants to know if that is realistic compared to others. To answer this, let's create the dot plot. We will first draw the number line and start from the lowest value and go all the way to the highest value from 0 to 7. And this is gym visits per week. So we'll go and put the dot above each of these number on the number lines. So there is 1 0, that means no visit at all. There is two ones, so they visit once per week. 4 twos. So we will keep plotting the data. Now our dot plot is ready. What stands out? I see that 3 visits is the most common. That's the mode. There are fewer people going 5, 6, and 7 times a week. This data is slightly right skewed because there is longer on this side, longer tail. If we draw a curve like this, there is a longer tail on the right side. So this is right skewed, meaning few people go a lot, but most stay lower. So where is Jordan's goal of 4? It's above the most common value, but still within the main group. So his goal is a little above average, but definitely reasonable. Now let me ask you this. Would going 6 or 7 times be typical or unusual? Now let's look at the money. Something matters in real life. Sophia spends $18 per week on food delivery and wants to know if that's too much. So to answer this question, let's again create the dot plot. So I start at 8 and went all the way to 30. Label this. This is weekly food delivery spending. There is 1 8, 2 10s. So let's go ahead and plot this. There is 214, there is 215, there is 318, there is 120, 122, 125, and 130. What values appear most often? I see that 18 appears the most, so that's the mode. Most values are grouped between 10 and 20. Yep, that's our cluster. But then we have higher values like 25 and 30, which are farther away. These higher values pull the data upward, but they are not typical. So Sophia's $18 is actually right in the middle. Very typical. Do you think $30 is typical spending? Why or why not? Explain in the comment section. So let's take a moment to reflect on what we have learned today. First is the mode. We learned that mode is the most frequent value on a dot plot. It is the tallest stack. That helps us quickly see what's most common. Second is the range. We also looked at the range, which tells us how spread out the data is, from the smallest value to the largest. This helps us understand variation. Third, we learned is shape. We talked about shape, whether the data is balanced, clustered, or skewed. Shape help us see patterns and understand what's typical. Next we learned is outliers. We noticed that one unusual value, an outlier, can change the data. That's why sometimes the median is more reliable than the mean. But the most important idea is this. Data only makes sense when we connect it to the real situation. Today, you didn't just read graphs, you used data to make decisions, compare situations, and explain your thinking. Before you leave, answer this. What is one thing a dot plot helps you understand better than just a list of numbers? Great work today. You are not just learning math, you are learning how to think with data. Thank you.